All right, in this lesson we're going to be talking about gas laws. Before we get into the gas laws, I want to talk about the unit pressure, because for gases, they're going to be applying pressure. We need to be able to work between the different units of pressure. We have three major units of pressure that we're going to be working with throughout the class: atmospheres, millimeters of mercury, and pascals. Pascals, abbreviated PA, because they're so small, are usually going to be actually kilopascals. So kind of like a kilometer, millimeter, it's going to be kilopascals. The relationship between the three is 1 atmosphere equals 760 millimeters of mercury equals 101.3 kilopascals. Just like in molar mass, where you had 1 mole equals 18 grams for water, one went on top, the other went on the bottom, depending upon what we needed. Same thing's going to be done here. All three of these are equal. Any one can go on top, any one can go on the bottom. So for example, if I want to convert 3 atmospheres to kilopascals, start with the 3 atmospheres. What do I want to cancel? I want to cancel atmospheres. If it's on top, 1 atmosphere goes on the bottom. What do I want? Kilopascals. Unit goes on top along with the number. And then that's going to give us our math, and it's going to come out to 303.9 kilopascals. So this is how we get between our units of pressure. Ooh, movement. Now let's actually get into the gas laws. Boyles' law. We're going to talk about 3 gas laws today. Boyles' law is the first one. Boyles' law puts pressure and volume into some sort of relationship. We're going to be keeping temperature and N, which is the number of moles. Those two things are going to be constant. What is the relationship between pressure and volume? Well, let's think about it. Well, if volume goes down, what's going to happen to pressure? So if we have container A and container B, they have the same number of particles. Let's assume the kinetic energies are equal, the temperatures are the same. If we have container A and container B, B is going to have a higher pressure. So if volume goes down, pressure goes up. They're moving at the same speed. There's going to be more collisions in B than there's going to be in A. More collisions with the wall of the container in B than in A. So pressure and volume are in this inverse relationship. But I want to make it a mathematical relationship. Well, pressure and volume, their math is going to need to equal some sort of constant. So I want to make a constant K. Well, if volume equals 1, pressure equals 1, K, no matter what we do, multiply or divide, it's going to be a multiplication or division relationship, K will equal 1. Well, if K is going to equal 1, then K needs to be 1 always. It's a constant. How can we get pressure times volume, or pressure over volume, to equal K? Which one? Well, let's use some different numbers. So if volume goes down, let's say volume becomes 1/2, what's going to happen to pressure? Well, pressure needs to go up, so pressure needs to become 2. Which one of these two situations will K equal 1? Well, if it's this, it's going to be 2 over 1/2. That's going to equal 4. 1/2 times 2 equals 1. That's going to be the relationship. Pressure times volume equals a constant. The way that we're going to use this in class is for a change in conditions. P1 V1 equals P2 V2. Original set of conditions, new set of conditions. If we change one, how is it going? If we change 1 to 2, how is the other one going to be affected?